Welcome to this tutorial on symmetry and point group in JMOL. In this tutorial, we will learn to draw line, that is axis, through atoms in a molecule, spin and rotate the molecule along the axis, draw plane through atoms in a molecule, and demonstrate point group classification. To follow this tutorial, you should have knowledge of undergraduate chemistry and familiar with operations from JMOL window. If not, for relevant tutorials, please visit our website. To record this tutorial, I am using Ubuntu operating system version 14.04, JMOL version 12.2.32, Java version 7, and Mozilla Firefox browser 35.0. Often, symmetry in molecules is described in terms of symmetry elements like axis of symmetry, plane of symmetry, center of symmetry, etc. We will use JMOL to display these symmetry elements in a molecule. Let us begin this tutorial by drawing C3 rotational axis through atoms in a model of methane. I have already opened the JMOL window. Click on the Model Kit menu to get the ball and stick model of methane on the panel. Label the atoms in the methane molecule by using Display menu in the toolbar. Click on Display, scroll down to Label and click on Number option. All the atoms in the methane molecule are now numbered. We need to write commands in the console to draw lines and planes through atoms. To open the console, click on File menu, scroll down to Console and click on it. A console window opens on the screen. We will use Draw keyword in the command line to draw lines and planes. Detailed information on JMOL script commands is available at this website. Open the website in any web browser. A web page opens with a list of keywords used for writing script commands in JMOL. Scroll down and click on the word Draw in the list. A page opens with details about the Draw keyword. A general syntax for the Draw command is given at the top of the page. This is followed by information regarding the use of the keyword. Let us now go back to the JMOL panel. I am using Kmax Screen Magnifier to magnify the console window. To draw a line that represents C3 rotational axis, type the following command at the $ prompt in the console. The command line begins with the word draw followed by object ID. Number 250 in the command line refers to the length of the line. This is followed by the position of the line. Within brackets, atom number equal to 1 and atom number equal to 2. Press enter. Observe the panel. A line passing through atoms 1 and 2 is drawn on the model of methane. This line can now act as an axis for rotation. We can draw more than one line on a given model. To draw C2 rotational axis, type the following command in the console. In this command, the numbers in the curly brackets indicate the Cartesian coordinates for the line, followed by a command to specify the color of the line. Press enter. Now on the panel, we have methane with C2 and C3 rotational axis. To rotate along the line 1, that is C3 axis, type the following command. Rotate space $line 1 space 60. The number 60 refers to the degrees of rotation. Press enter. Observe the rotation along line 1. To spin the molecule along line 1, type the following command. Spin space $line 1 space 180 space 60. The number 180 refers to the degrees of rotation and 60 refers to the speed of rotation. Press enter. On the panel, we see the methane model spin along line 1, that is C3 axis. As an assignment, draw a line representing C3 axis of symmetry in a model of ethane and spin the model along C3 axis. Back to the JMOL panel, we can also draw planes going through a set of atoms in a molecule. To do so, first delete the lines on the methane model by typing the following command. Draw space off. Press enter. To draw reflection planes going through atoms 1, 2 and 3 of the methane molecule, type the following command in the console. Number 300 in the command indicates the size of the plane. Press enter. Observe the reflection plane going through atoms 1, 2 and 3 in the methane molecule. To draw a second reflection plane through atoms 1, 4 and 5, in the console, press up arrow key and edit the command as follows. Edit plane 1 to plane 2 and atom number 2 to 4 and atom number 3 to 5. Also, to change the color of the plane, type the following command. Semicolon, color, space $plane2, space blue. Press enter. On the panel, we see the two reflection planes in a methane molecule. Using JMOL, we can also show point group classification for methane as follows. Let's clear the planes drawn on the methane molecule on the panel. In the console, type draw space off, press enter. To display all the possible symmetry elements for methane, type the following command in the console. Draw space point group, press enter. We see the symmetry elements of methane displayed on the panel. To find out the point group classification for methane, type the following command. Calculate space point group, press enter. TD, the point group of methane molecule, is displayed on the console. Another classic example for point group demonstration is alene. We can draw the structure of alene on the panel using the model kit menu, or we can also download the structure of alene from chemical structure database. If you are connected to internet, click on the file menu, scroll down to get mol and type alene in the text box. Click on OK. To display all possible symmetry elements for alene, press up arrow key at the dollar prompt on the console till you get this command. Draw point group, press enter. Observe the panel. We see all possible symmetry elements for alene. To get the point group classification for alene, again on the console, press up arrow key till you get the command calculate point group. Press enter. The point group classification for alene, that is D2D, is displayed on the console. Similarly, you can download molecules of your choice and calculate their point group. Let's summarize. In this tutorial, we learnt to draw lines, that is C2 and C3 rotational axis, through atoms in methane molecule, spin and rotate the molecule along the axis, draw reflection plane through atoms in methane molecule, and demonstrate point group classification using examples of methane and alene. As an assignment, draw a reflection plane in a model of dichloromethane and find out the point group classification for ammonia and benzene. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials and give certificates. Please contact us. The Spoken Tutorial project is funded by NMEICT, MHRD, Government of India. This is Snehalata from IIT Bombay signing off. Thank you for joining.